All right, hello, Mr. Beeland here. Your lesson today on functions. Okay, so a function is a special relation, it's a special type of relation between values where every input has exactly one output. So for everything you put in to your relation, it will go to one output. Okay, it won't go to 2, it won't go to 0, it won't go to 3, it goes out to exactly 1. Okay, so what does this look like? All right, so I've got two ordered pairs here. Let's look at those first. Two ordered pairs, and these are relations, right? Because it's a set of ordered pairs. And we just need to look and see, is this a relation or is this specific special relation known as a function? The way we do that is we see that every input has exactly one output. So let's have a look here. 10 goes to 6, so that's one input going to one output. 5 going to -2, 7 to 9, 11 to 1. So all of our x values are corresponding to a particular y value. So this is a function. Now if we look at this one, -4 goes to 1, okay? -1 goes to 7, and then it says -1 goes to -2. So that would mean that -1 goes to both 7 and -2. So because you are now having an x, or an input, we're going to say that x is the input, your 1x is going to two different outputs. That means this is not a function. Okay, this is just a relation. It is not a function. Okay, so we're going to put an x beside that one. All right, so there are a whole bunch more examples in the notes there. You can go around, you can just do a quick test on those, right? Just look at your ordered pairs and see if that x value pops up twice. If it does, then it's not going to be a function. But with our relations, we did have a couple other different ways that we were looking at the relations, right? We were also looking at mapping and at tables. So let's have a look at a table example. This one is actually number 5 in the notes there. So I set up my table, 3 to 5, good. 1 to 0, or -1 to 0, sure. 0 to 1, 2 to 2, 3 to 5. So what we actually see here is that 3 is popped up twice. So 3 is going to map to both 5 and 3, which means that the input has two outputs. That's no good. So number 5 here, this table is not a function. All right, so now let's look at this one here. Okay, this is a mapping one. -3 is going to 0, -1 is going to 4, 2 is going to 7, and 4 is going to 4. So the important thing to see here, or the initial thing that you might see is, well, you've got two different things, -1 and 4, going to 4, right? So now you've got two inputs mapping to one output, and you may initially think that, well, then that means it's not a function. In fact, it is still a function because each input only has an arrow going to one output, okay? This would be like saying, you know, for example, your function is multiplying by 0. So you could have -3, and your function is multiplying by 0, you get 0. And then you multiply by 2, or you take 2 and you multiply by 0, you get 0. Everything would end up mapping towards that 0, right? So you can have multiple inputs going to the same output, but you cannot have an input splitting off into multiple outputs, okay? That's very important. So even if you have doubles on the y side, that's okay. You just can't have doubles on the x side. So this is a function. Okay, and again, these are all going to be discrete, right? Because they're specific points and stuff. But as we saw, there was another way that we could look at some of these things, or these functions, and that was with continuous, right? Continuous graphs. So we can't really do a table, and we can't really do mapping and ordered pairs with a continuous graph. So let's have a look at something called the vertical line test. So whenever you have your graph, say your graph looks like this, sure. The vertical line test says if a vertical line intersects with more than 1 point, then it's not going to be a function. So these ones are actually pretty cool, right? Because on continuous, again, we're going to be dealing with graphs for the most part, and it's using the vertical line test. So how can we do that, right? Well, we can take our pencil or our pen or whatever, and we're just going to make sure to put it straight up and down. We're going to start at one side of the function, and we're just going to run it from left to right. And if this function, or this line here that we think might be a function, is so long as it doesn't touch two spots on the same part of your, or two spots in your, on your pen or pencil, it is a function. So as we can see, I'm only intersecting one spot on my pen. So this would be a function. But then if I was to look at something like, say, the circle example, right? As soon as I move over to, like, say here, I can see that I'm touching a spot right here and right here at the same time on this vertical line test. So by the vertical line test, this circle fails. It is not a function. It is just a relation, okay? And again, that's saying that you have your x value, say for example, this is +1. Well, now you're mapping to this point here and this point here, whatever they are. You're mapping to both of those, right? And we just said that you can't do that because it has to be exactly one output. Okay, so again, there's a whole bunch of examples there on the paper. I think there's like 8. Please have a look at them. Use the vertical line test. It's kind of it's a pretty easy little trick, right? So I don't think it'll be too much trouble. And then that is pretty much it. Okay, take care.